Why do waters sometimes appear blue or green? We know that water is colorless, right? So why sometimes, for example, if you look at glacial melt, fresh glacial melt, rivers that are coming from the glaciers, they often appear green. I've seen many examples of such. At the same time, if you look at tropical waters, you know, we look many times at the ads by travel companies showing the Caribbean and the blue and green waters. They really are alluring, but how do they get their color? Well, the first thing we think of is minerals. So think about glacial melt. So the ice is melting into the river, and if the ice contains various minerals, then these minerals will be included in the water. And the water may turn a different color simply because of those minerals. Interesting hypothesis, but you know, minerals run out, and if the ice has a certain mineral content, you'd expect that after a certain number or a certain rivers form, eventually the ice will be depleted of the minerals, and the river will no longer have the color, but it does have the color. And so that is not a very probable hypothesis. I'd like to suggest to you a different explanation, and this explanation has to do with easy or fourth phase water. We found that that when you freeze water, the frozen water, the water doesn't transition directly from water to ice. There's an intermediate phase, and that intermediate phase is easy water. So you have water turns into easy, which turns into ice. And the structures of easy and ice are both hexagonal. So they're not the same structure, but there's a kind of similarity, so you can understand. And the same thing happens when ice melts. When ice melts, it doesn't melt directly into liquid water. In fact, it melts into easy water, and then eventually into liquid water. So I'd like to suggest to you that the reason for the colors have to do with EZ. Now, is EZ colored? Well, not exactly colored, but it does fluoresce, which means you put a certain ambient light into it, and the EZ water becomes a particular color. And so you can imagine this happening, for example, with the melt of the ice. The ice melts, it melts into EZ, and the EZ fluoresces, which means that when the ambient light is received by that EZ water, the EZ water gives off a certain color. And that color typically, depending on the wavelength of the incident light, typically it'll be blue-green, sometimes blue-violet, sometimes green. It depends on the wavelength of the incident light. So we can understand why the rivers, the glacial melt, consistently have color. And it's pretty much the same with the Caribbean waters. You know, they contain microorganisms. It's warm air. And the microorganisms are filled with EZ water. And in fact, the EZ water extends beyond those microorganisms into the immediate environment. And it's warm. We found that warmth, infrared energy, the two are virtually the same, not exactly the same, but it's the infrared energy we found that builds EZ water. So the Caribbean waters and other warm waters are simply filled with this kind of EZ water that fluoresces, and that's why it has color. So it's not only a treat for your eyes, but also I think we have some fresh understanding about why these waters appear to be colored, deeply colored. Water, the stuff that's inside this cup, really is colorless. What I'm suggesting to you is that the reason you see color is you're not looking at liquid water, you're looking at least in part, at EZ water. And EZ water fluoresces. And the color of the fluorescence depends on the wavelengths of light that are incident onto the water itself. So I think you can count on on seeing rivers that are green and Caribbean waters that are bluish, greenish, essentially forever. It has to do with the fluorescence of easy water.